In our previous lesson, we have already read that Ferdinand Magellan circumnavigated around the earth and proved that our earth is round. That is, he left Spain and travelled around the world and returned to the same place. So the circumnavigation of the earth by Magellan is the first tangible evidence that proves that our earth is round. Now later on, more evidences cropped up which proves that our earth is round. Let's look for those evidences. Look at this beautiful sight. You can see this sight while walking on a beach. It seems as if the sun sets in the sea. This is known as horizon. Now horizon is the place where sky and the sea appears to meet or blend with each other. So this line where the sky and sea appears to meet is the line of horizon. Now, have you ever wondered why do the sky and sea appear to meet if they are miles apart? Suppose our earth is like this, that is, it's a flat earth, and an observer is watching this tree. So the observer will never see the sky and the land to meet because the vertical distance between the sky and the land will be the same throughout. So this gap between the sky and the land would extend till infinity in case of the flat earth. But in reality, what do we see? In reality, we see the sky and the sea to be meeting. Consider this observer. So when this observer sees the tree, after some point of time, it sees the top of the tree and the sky meets. This is because the vertical distance between the sky and the land decreases. See, the vertical distance between the sky and the land here is this much, but gradually the distance decreases and finally the sky and the top of the tree appear to meet, and this is the reason why we see horizon. So horizon is a mirage or an optical illusion where we can see the sky and the land surface to meet, and this happens because our earth is spherical and not a flat surface. So horizon is an evidence of the round earth. Now let's look for other evidences which proves that our earth is round. Here we have a chart that shows the time of sunrise and sunset in two different cities, that is Tokyo, situated in Japan, and Washington DC, situated in USA. It also shows the hours of daylights in these two cities. Now, if we consider the case of Tokyo, we can see that the time of sunrise is 6:48 AM in the month of January, and the time of sunset is 4:52 PM. The hours of daylight is 10 hours and 3 minutes. Now, in the same month, the time of sunrise is 7:23 AM in Washington DC, while the time of sunset in the same month is 5:11 PM, and the hours of daylight is 9 hours and 48 minutes. Now, not only for this month, but the time of sunrise and sunset varies in both the cities for rest of the months as well. See here the time of sunrise is 5:07 am and here the time of sunrise is 6:29 am. Similarly, the timing varies for the rest of the months and also the hours of daylight varies. So we find variations in time of sunrise and sunset in these two cities. And also here we find a fact that the time of sunrise is ahead in Tokyo than in Washington DC. In fact, Japan is called the land of rising sun. Do you know why? Well, earlier I have mentioned that the earth is spherical. But here we have considered a flat world map. This is done just for convenience. Now here if we divide this world map into two parts vertically, then this is the eastern side and this part is the western side. Now from this map we can see that Japan lies in the eastern part of the world. In fact, Japan lies in the extreme east. And due to this reason, this country is the first to see the rising sun. And due to this reason, Japan is known as the land of rising sun. Now, why do you think Japan sees the sunrise first than other places of the world? If our earth would have been a flat, then all the places on the earth would have seen the rising sun at a particular time. See, if here is the sun and this is the flat earth, then all the places would have received the sunrise at the same time. But this is not the case in reality. In reality, we find that some parts of the earth receive the sun first and rest of the part receive the sun later. This happens because our earth is spherical in shape. Now our earth rotates from west to east. So the eastern part of the globe sees the sun first and then as the earth turns, then the western half also sees the sun, but it sees the sun later. So the spherical shape of the earth justifies why the time of sunrise and sunset varies all across the globe. So now do you understand why Japan is called the land of rising sun? This is because it is located in the extreme east and it receives the sun first, while all other places experiences sunrise later because the earth is not flat but it is spherical. Now not only the time of sunrise and sunset varies, but also the inclination of sun rays varies, which gives us some idea about the earth's shape. Let's see how. Alexandria and Sene are two Egyptian cities. Now, a resident of Alexandria, Eratosthenes, had heard from the travelers of Sene that sun cast no shadow in a well at noon on a particular point of year. However, at Alexandria, which is 800 kilometers away from Sene, he observed that a pole is casting its shadow on particular date and time. Now this confused him as objects at one place were having shadows while objects at another place were not having shadows at same date and time. So he carefully investigated this fact to find out the logic behind this. In the previous video, we saw that at Alexandria, the pole was casting its shadow, while at Sene, the well had no shadow at the same date and time. Now, Eratosthenes calculated the angle between the shadow and the rays of the sun, and he found it to be 7.2 degrees. He also discovered that the Tropic of Cancer passes through Sene, whereas the Tropic of Cancer does not pass through Alexandria, which is 800 kilometers apart from Sene. Now it was found that the sun rays were perpendicular or vertical at Syene, while the sun rays were inclined at an angle of 7.2 degree at Alexandria. Now since the sun rays are vertical at Syene, so the well at Syene had no shadow, while the pole at Alexandria had shadow. This is because the sun rays are not perpendicular here, rather they are inclined at an angle of 7.2 degree. So from this we can infer that the inclination of sun rays varies with latitude. At Tropic of Cancer, the sun rays are perpendicular, but if we move to higher latitudes, then the sun rays are inclined at some angle. But if our earth would have been flat, then the parallel rays of the sun would have struck the surface at a definite angle. But since the earth is spherical, so the sun rays strike the surface of the earth at different angles. At some point they are perpendicular, while at other places they are inclined at some angle. So from the variation of inclination of sun rays with latitude, we can infer that our earth is not flat, rather it is spherical. We know Earth and Moon are not stationary. Earth revolves around the Sun and Moon revolves around the Earth. Now during this process, it so happens that the three celestial bodies are aligned in such a way that Earth obstructs the light of the Sun falling on Moon. So the Sun projects Earth's shadow on Moon. This is known as lunar eclipse. So lunar eclipse occurs when Moon appears darkened as it passes through the Earth's shadow. See here, the Moon is passing through the Earth's shadow, and as a result of which it is appearing darkened. Now lunar eclipse can be of two types: total lunar eclipse and partial lunar eclipse. During total lunar eclipse, the Moon is completely overshadowed by the Earth, and this happens when the Moon is in the dark region, and this dark patch is known as umbra. So when the Moon is in the umbra region of the Earth's shadow, then we can see total lunar eclipse, while sometimes only a part of Earth's shadow fall on Moon, and during these cases we have partial lunar eclipse. Look at this picture. In this picture we can see different phases of lunar eclipse. This one is the complete lunar eclipse. During complete lunar eclipse, we can see this type of moon, which is blood red in color, and here the total shadow of the Earth falls on Moon. Now in these cases you can see only a part of Earth's shadow falls on Moon. Thus all these represents partial lunar eclipse. Now in both cases of total or partial lunar eclipse, we can see a circular shadow of the Earth. See here, a circular shadow has fallen on Moon, and in these cases also we can see circular shadow of the Earth. Thus circular shadow of the Earth during lunar eclipses proves that our Earth is not a flat body, rather it's a circular body. This is because only a circular body can cast a circular shadow every time. Thus the circular shadow of the Earth during lunar eclipse proves that the earth is a round object. Now before we proceed with our lesson, let us try to answer this question. What is the shape of the earth's shadow during lunar eclipse? Is it rectangular, circular, triangular or conical? Well, the correct answer is circular. The earth casts a circular shadow on moon during lunar eclipse. Have you ever visited a harbor and observed a ship approaching towards the shore? If you have done that, then what do you see? You first see the mast and then its funnel and then the hull, and finally the entire structure of the ship is visible. But if our earth is flat, then the entire ship would have been visible from the beginning, isn't it? A series of similar observations was conducted in Bedford Canal area, which is situated in United Kingdom. The bottom of the canal was taken as the base measurement, and 3 poles were placed at an interval or gap of 5 km at the base of the canal. Now, the 3 poles were kept in such a manner that they rise at same height from the base of the canal. The aim of this Bedford level experiment was to prove the curvature of the earth. Now, let's see what is the conclusion or inference of this experiment. An observer took a telescope and viewed these 3 poles. What did he see? He saw that the top of pole A was lower than the top of pole B, while pole C was not visible at all. What happened? What happened is that the side of visibility was interrupted by pole B, and that's why pole C was not at all visible to the observer, and this happened because our earth has a curved surface. So the inference of this experiment was that the line of visibility increases with increase in height. So pole B appeared to be more elevated than the other 2 poles. So the Bedford level experiment proves that our earth has a curved surface and not a flat surface. Now here we have a satellite image of the earth. Many such images have been taken by artificial satellites and spacecraft. Now all these images shows that our earth is circular in shape. In fact, this satellite image of the earth and aerial photographs are concrete evidences that proves that our earth is round. So, in today's video, we read about different evidences that proves that our earth is spherical in shape. The first evidence which proves that our earth is round is Circumnavigation of the earth by Ferdinand Magellan. Next, there are other evidences which proves that our earth is round, and they are Bedford level experiment, variation in time of sunrise and sunset, variation in the inclination of sunrays, and circular shadow of the earth during lunar eclipse. Now, a concrete evidence which proves that our earth is spherical in shape is the satellite image of the earth, because from this satellite image we can clearly see how our earth looks like or what is the shape of the earth. So these are different evidences which proves that our earth is a sphere. In our next video, we will discuss about the shape of the earth and unique features of our planet Earth. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million+ questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.